Hey y'all. All right, so today we are doing homework for 523. So we're going to start with 5-47, which says that Ariane claims that this point, 3, 6, is the intersection of these two lines. Is she correct, and how do we know? Well, we can go ahead and plug in this point into each of these and see if that is correct or not. So for our first equation here, y equals 4x minus 2, we're just going to plug in the 6 for the y, right, because this is a y value, and then the 3 for the x. So plugging that in, we have 6 equals 4 times that x value, which was 3, minus 2. And we can go ahead and solve this and see what we end up getting. So 6 stays on the left. On the right, we can do our multiplication. 4 times 3 is 12, minus 2. Let's do our subtraction. 6 minus 2 is 10. 6 does not equal 10, so we have to put a slash through that. That does not work. Let's try it in the other equation, the same point. So y again was our 6 equals, I'm going to convert this 1/2 just to 0.5. I like working with decimals more than fractions. Times our x value, which was 3, plus 5. So then when we go ahead and we multiply, right, 0.5 times 3 is 1.5 plus 5. We have to go ahead and add. So we end up with 6.5. 6 is not equal to 6.5. So is she correct? Unfortunately, she is not. She is not correct. If she was, these two would be equal, and they're not. The point doesn't make either true. Okay. All right, so that's how we know. Next problem here, we have 5-48. We need to graph these two lines, first of all. So this first equation of y equals 2x minus 3, we know that our y-intercept is -3, so we're going to start with a point right there at -3 on our y. And then we know that it grows by 2, so that means we need to move up 2, 1, 2, and over 1. Again, up 2, over 1. We can just continue to do that until we get a few good points on our graph. I can also grow it in the other direction by starting again with -3, moving down 2 and over 1 to the left. So down 2, left 1, right? Okay, so that's a good amount of points. We can go ahead and put our line through those points. There we go. All right, now we can go on to our next equation, which is y equals -x plus 3. So since it's positive 3 on my y-axis, I'm going to go up to positive 3 and put my first point there. Now I see that my growth this time is negative, and since it's just a -x, that's like saying a -1. So that means that I'm going down 1 and then to the right 1. So down 1 to the right 1, down 1, over 1. We can just kind of continue it for a few points like that. I can also grow my line in the other direction by going up 1 and then to the left 1. Just get a couple points on here. Okay, that's pretty good. And we can go and connect them just like that. All right, so we have graphed them. Now, where do they intersect for A? We need to label the point on our graph. I can see that they touch right at this point right here. And if I'm going to label that, I can come over on the x, 2, right, and then going up 1. So my point would be 2, 1 for the intersection point. Now I need to find the point of intersection using equal values method. So that's using more of the algebra equation. Let's start by combining both equations into one equation so that you can solve for x. So what that looks like is we basically are taking these two equations and we're taking the y off. So we're going to put them equal to each other. So 2x minus 3 equals -x plus 3. Okay, making equal values means making them equal, setting them equal to each other. And then we solve for x. So first, I'm going to combine my x's by adding an x on either side because I have that subtraction sign there. So adding x, when I add these together, I get 3x minus 3 equals 3. Okay. Then I need to move this negative 3 over onto the other side, right, to get those equal to each other. So I'm going to add 3 on both sides. So I'm left with 3x equals 3 plus 3 is 6. Lastly, I need to get rid of my coefficient, so I'm going to divide by the number out front, dividing by 3 on both sides. So I'm left with x equals, and then 3 goes into 6 twice, so x equals 2. Now, I am not done there because I need to find both the x and the y. In order to do that, I'm going to plug these in, the x number in. So I'm just going to put a squiggle down there. And then I can plug this 2 into either equation and solve for x. So I'll just plug it into the first one. Y equals 2. Now, instead of that x number, I'm putting in my 2, right? Because that's what x equaled here. And then minus 3. So we know that 2 times 2 is 4 minus 3. 4 minus 3 is 1. Okay, so y equals 1. And I can do it on both equations to prove that it's correct. So for my other equation, y equals negative, plugging in that 2 again, plus 3. So we essentially have negative 2 plus 3, which we know is 1. So for sure, we can see our points, right? X is 2 from up here, and y is equal to 1. So that means that it checked out with equal values method. All right, flipping over to the back, we are now asked to solve for the variable. Okay, we've kind of been doing ones that are very similar to this. First, we need to find a common denominator, right? Because we can't add or subtract fractions that don't have common denominators. So we're going to take our first fraction, the 7y over 8. And I can see that 5, I just like to multiply these two numbers. If like 5, there isn't a number I can multiply by 5 to give me 8, I just like to multiply these two, which will give me a common denominator. So 5 times 8 is 40. So I can use 40 for both of these equations. So we had 7y over 8. Now what times 8 will get me to 40? 5 will. So I have to multiply both the top and the bottom by 5. So we know that this should equal 40 on the bottom. So then when we multiply our top, 5 times 7 is 35. Y. Okay, so this equation right here, or this fraction, is equivalent to that. And then down at the bottom here, I'll just rewrite my negative 3, or sorry, my 3y. I'm just going to subtract them when we get done. 3y over 5. What do I need to multiply by 5 to get me to 40? 8. Multiplying by the top by 40. Okay, so the bottom is my denominator is going to be 40. And we know that 8 times 3 is 24. So 24y, this fraction represents this one. So now I'm just going to rewrite my fraction so that it looks a bit nicer. So 35y over 40. Remember that subtraction sign, right, from right there. And minus 24y over 40 equals 11 over 2. And I'm just pulling that from our original equation. Okay, so now we can go ahead and subtract, right? So when we, first of all, subtract, we have our 35 minus our 24, which we know is 11. So 11y over 40 equals 11 over 2. Just like that. Okay, then we are trying to get y by itself. So right now we're dividing by 40, so we need to multiply by 40 on both sides. So we're left with 11y equals, and then when we go ahead and multiply these by 40, we end up with 20. Oh, I forgot to divide my 11 though. Sorry. Y equals 20. There we go. Okay. There's that one. Okay. Now on my next one, I have denominators of 3 and 7. So again, I need to find a common denominator. I could also do a fraction buster, which I suppose I could show you, where I'm going to take my denominators and I'm going to multiply my numerator by that, each of those. So a 3, a 7, and a 5, because those are my 3 different denominators here. So I'm going to multiply by 3, 7, and 5. Just like that. And then I can cross cancel. So the 3 will cross cancel here, the 7 will cross cancel there, and the 5 will cross cancel there because, right, 5 divided by 5 is 1, 7 divided by 7 is 1, 3 divided by 3 is 1. So what are we left with? Let's see. All right, so we have 7 times 5 is 35. So we have 35a plus 37, or sorry, 5 times 7 is 35 plus 4 is 39. And then, so that's this first fraction, minus, right, 3 times 5 is 15, so 15a equals 3 times 7 is 21. 21 times a would be 21a. Again, 3 times 7 is 21, plus 7 is 28, so plus 28. Okay, so we're able to kind of bust up those fractions. That's a nice time to use a fraction buster method. Now we need to combine some of our like terms. So I can see I have a's on the left side that I can combine. So when I take 35a minus 15a and I subtract those numbers, I get 20a. Plus 39, can't do any combining there just yet. And then 21a plus 28. Can't combine anything on the right side. Now, though, we need to get our a's together, right? So I'm going to start by subtracting 20a on both sides to move this 20 over to this side. And I just did that to keep my a's positive. So I'm left with 39 equals 21 minus 20. We know it's just a, just 1, plus 28. I can subtract my 28, right, to get my a's alone by themselves on the right side there. And then when I subtract, I should get negative, wait, hold on. 39 minus 28 equals 11 equals a. And then a equals negative 7. All right, so there is that answer. Okay, 5-50. It says we need to graph these two lines and see where they intersect. So I'm just going to make a set of axes, an x and y, on my paper here. Just like that. And that. Okay, so graphing my 2 points. Starting at -3 for my first line. And then growing by 2, so going up 2 and then to the right, since we're increasing in a positive direction. And then I can also grow my line in the other way. Okay, and we can connect these points like that. And then my second line, right, my y equals 2x plus 1. Since my y-intercept right here is 1 on my y-axis, I find the 1. And I'm going to grow it by 2, 1, 2 over 1 every time. You can kind of see what's happening here. I can grow it in the other direction as well. And you guys can tell these lines, right, are not going to touch. These are called, right, parallel lines, meaning that they are going to run equal to each other and they're never ever going to intersect or touch each other. So where did they intersect? They don't, right? So they're growing by the same amount every time, that 2. So they don't intersect. So then solving this system using equal values method, we would just put these two equal to each other, taking off the y part. So 2x minus 3 equals 2x plus 1. When I subtract 2x on the other side to try to get them equal, I end up with negative 3 equals 1, which do not equal each other. So we'd call that no solution. And then explain how your graph and algebraic solution relate to each other. Well, parallel lines, we can see on our graph, parallel lines don't intersect. And that's all you really need to say for that one. All right, flipping it over, we just have one more on this side, number 51. Janelle came to bat 464 times in 131 games. At this rate, how many times should she expect to have at bat in the full season of 162 games? When we're given numbers like this kind of screams set up a proportion. So that's what we're going to do. She bats 464 times in 131 games. So let's set that part up. So 464 times at bat in 131 games. And I just put the labels there just to kind of keep it all straight, so that I make sure that this other side is lines up. So then it's saying that in a full season, there are 162 games. So I know that that goes with the games on the bottom of my fraction, 162 games. And I want to know how many times she's going to be up to bat. So that's going to be my x value. Okay. So now I'm probably just going to cross multiply to solve this. So multiplying 131 times x would be 131x equals my 464 times 162 is a really big number. 75,168 to be exact. All right, and then to solve for x, I need to divide by that coefficient number out front, 131, on either side of my fraction, because since we're multiplying here, we're going to do the opposite to get rid of it. So that leaves us with x equals, and when we go ahead and divide these numbers, it's not a great number, so I'm just going to use, it's a decimal, so I'm going to use the about sign. It's about 500, and I'm just going to round that to 74. 574 times at bat. All right. Hopefully that makes sense. If not, let me know.